Hello everyone, my name is Matias Grignola, and today I will be talking about data analysis, also known as data analytics. So to begin, we have a definition. So analytics is the process of inspecting, grouping, cleaning, and modeling data. The end goal of data analytics is discovering useful information to be applied to certain fields such as business, medicine, science, engineering, etc. So the biggest component of data analytics is data mining. Data mining is the computation process of discovering patterns in large data sets. This can involve artificial intelligence, machine learning, statistics, and database systems. So these are all things that do data mining. The goal from data mining is to extract useful data from a data set and transform it to usable data that the user can then use to support ideas or make big decisions. So data mining is part of a process known as Knowledge Discovery and Database, or KDD. It is separated into 6 stages, and they are selection, pre-processing, transformation, data mining, interpretation, and evaluation. So this is the general understood stages of processing data and data analytics, but there is something else that narrows it down to the most important ones, and this is the cross-industry standard process for data mining. It's a mouthful, but the more condensed stages are pre-processing, data mining, and results validation. So pre-processing, this must be done before algorithms and models can be used. So what pre-processing is that a target data set must be assembled. So as you can imagine, there is a lot of data in the cloud and databases, things like that companies collect. And to get reliable data sets, they need to accumulate relevant data. So if you're trying to, say you're Home Depot and you're trying to aggregate data on a certain type of lumber that people buy, you can't just take all the data of all Home Depot's products to try to infer some statistical significance on a certain type of lumber. So a target data set must be assembled. They need to be large enough to where patterns and models can be taken from these data sets, but at the same time, they need to be concise enough to where programs can do the job in a reasonable amount of time. So basically, pre-processing, what it does is removes all the unnecessary data, removes all the noise, all the trash that you don't need in order to apply algorithms to significant data. The next part is data mining, and of course, there are categories within this. There's 6 classes of data processing, and they are anomaly detection, association, rule learning, clustering, classification, regression, and summarization. Most of these are pretty self-explanatory, but the 2 that I want to highlight are clustering and classification, which are at the core of data mining. So clustering and classification. Clustering is when you group data into similar groups with similar structure and commonalities. This is where you take relevant data, put it into specific categories. But then classification is applying known structure to the new data. So this is when you already have a certain process of dealing with new data and you apply it to this new data. For example, when using email, email programs use data mining to figure out, they specifically use classification to figure out which emails are spam, and they then relocate these spam emails into a spam folder and remove it from your inbox. This is an example of a classification, a structure that is applied to new data. So the structure is spam, and it applies it to new data, which is a new email. Next is results validation. So this is huge. This makes sure that patterns produced by data mining and algorithms are correct. So sure, you may have gotten a pattern. There may have been something that you could model off of, but doesn't necessarily apply to what you're looking for. Results validation helps prevent the misuse of data, which is possible either on purpose or an accident. However, once the data is validated, you need to check if it meets the standards and the requirements. So even if the data is valid, it might not meet the standards, so you'll have to go back and edit these processes in such a way that the next time around you'll get data that is actually useful to you. So there's a lot of data mining uses. As you saw, it is used in numerous applications. One of the most mundane ones are email programs. So like I said, data mining is an email program, so you can imagine the amount of complex programs that are used in different fields. And some of these fields are business, science and engineering, medicine, human rights, surveillance. All these things benefit greatly from data mining. So data mining in business is huge. It's absolutely huge. This is where big corporations kind of have a huge advantage over small businesses, since they have such a large data pool that they can use data data mining to predict patterns and trends. They can better quantify their supply and demand, which in turn reduces costs and maximizes profit. They can see customer purchasing habits, which is really neat. So apparently, a study came out with Walmart, and they released what people buy most during times of like tornado warning or hurricanes, and allegedly it's bottled water and Pop-Tarts. So if they know this, they can relocate their stock in different stores to better help the needs of the people and therefore increase their sales. Um, Again, they can take data from product usage. So if you're using electronic devices, for instance, Apple asks you if you want to send analytics reports back to them. And this is to see how you use the product, so that they can better it and keep selling. They can also identify manufacturing issues with data mining. This is all through computers and things like that. So here you can see how big businesses have a huge advantage over the small ones. Data mining in science and medicine. The ability to map the human genome, that was due to data mining. And this has been huge in terms of being able to diagnose people with the correct disease and treatment. And it has also helped diagnostics in terms of being able to correctly identify diseases due to symptoms due to past patient data. So overall benefits of data mining, it has greatly helped the economy, improve revenue for businesses, especially the big businesses that contribute most to GDP. They are able to cut off costs, make processes more efficient, also helps detect fraud and abnormalities in systems and processes. So imagine the spam and email example. Imagine that applied to just general huge processes that companies have. Disadvantages, however, are there's immense amount of data, and you run the risk of using incorrect data and arriving at incorrect calculations. So thank you for watching. Hope you learned something, and here are my sources. Thank you very much.